All right, so today's lesson is on significant figures. And significant figures is a confusing or a frustrating lesson for most high school students for one simple reason. It requires you to know and obey rules. Okay? So the rules are what I've given you on the handout. All right? And so like any other rule, if you don't follow the rule, don't expect a good outcome. All right? So again, in this case, it means if you don't follow the rule, don't expect to get the answer correct. All right? So what I mean by that is this. If we look at this, and you don't have to write it down because I'm just throwing this up there for you to understand. All right? If you see, I've written down 4 numbers on the board. Okay? So, just to see, hopefully we don't get the first 3 numbers wrong, but we'll find out nonetheless. All right? The first number, George, is what number? 1,000. Okay? Mr. Coburn, what's the second number?
1,000.
1,000. All right? Donovan, what's the third number? 1,000. All right? And just for our case, so I won't even make somebody say it. And the fourth number is 0.00001. Okay? We won't go into like the tenths, hundreds, thousands, 10,000s, all that stuff. We won't worry about that. That's not the point. All right? The point, though, is this. That number right there has one significant digit. All right? That number right there has 4. That number right there has 5. That number right there has 1. Okay? So each of those numbers, like in the first 3, all of them are 1,000. But not all of those zeros count in the 1,000. Sometimes none of them count. Sometimes all of them count. Sometimes one will count and not the other. So it can be confusing because what happens now, if you recall on Friday, we did a calculation with when we were doing multiplying scientific notation. And I said multiply the integers. And then you said when you get to multiply the integers, some of you gave me this number. You said 5.667. You don't need to write this down. You said 5.667, right? Well, guess what? Sometimes that would be the right answer. Sometimes that would be the right answer. Sometimes that would be the right answer. Sometimes that might be the right answer. Like today, if you give me that, but it should have been that, you're wrong. If you give me that, but it should have been that, you're wrong. Like today, you can't just round to how you feel because facts don't care about your feelings. Okay? Today, you're going to round, but you have to know how many should I have when I round. And that's where the rules come in. The rules tell you what you should have. That's why it's going to be important that you pay attention to your rules and you obey them. Like it's more than just knowing them. Like I know the speed limit going down the road is 60 miles an hour. I think they changed it from 55 to 60. All right? I think. Yes, they did. All right? So I know it's 60 miles an hour. But if I go 65, knowing the rule didn't mean anything, I'm still going to get a ticket. Okay? So again, you got to be able to know them and obey. And that's the whole issue here. You can know it, but if you don't obey it, your answer is going to be wrong. And you're going to get frustrated because you're going to say, hold on, I got 5.667. Right, and I'll say, yeah, but the answer should have been 5.67. What? That'll make sense. It does make sense if you know the rule. But if you don't know the rule, then nothing makes sense. Okay? Are we kind of aware of why we need to focus on the rules now? That's what I'm going to do. I'm going to go through the rules step by step and make sure we understand what we're looking at. All right? So, the first thing, though, like on Friday, is we need to know why do we need significant figures in the first place. Okay? So that's where we get to the first question. This is what we're looking at right here. What are significant figures? Significant figures for me are numbers that are important in a measurement. All right? Because when you measure things, you're going to get, you're going to get numbers, but sometimes some of those numbers are valid, some of those numbers aren't valid. So the way I always refer to significant figures is, would you bet your life on it? Like if somebody give you an answer, would you bet your life on it? All right? Simply put, all I got to do right now is this. I'm going to just take this right here. Okay? I've drawn a line on the board. Okay? Everybody's looking at the exact same line. Okay? But here's what I want you to do. Right now, if we were going to measure the distance of that line in inches, then I want you to know just by your observation, I mean, you've been living your entire life with distances. So my question is this. If you had to guess what you believe that distance to be, how many inches do you think the distance of that line is? Just take a guess. Think for 10 seconds before you say anything. Best to think before you speak. All right, everybody's got a number in their head? All right. So let me go to Jayla. Jayla, how many inches do you think that line is in distance? 5? All right, she's going 5. Nathaniel?
About 7.
About 7, all right. George? 7, all right. Alondra? 6. So we had 5, 7, 7, 6. All right, anybody got a number they think is different than 5, 7, 7, 6? So everybody's kind of, they're thinking in that range. Okay, nobody's, okay. So let me see if I have a ruler right here. Okay, here we go, I do. Okay, here's a ruler, right? This is a ruler, so therefore this ruler is about how long? 12 inches, right? So here's all I'm going to do right now. I'm going to take this right here, and I'm going to throw it like that. Everybody see that right there? If you didn't, I missed it. All right, let me try it again. There you go. Okay, you now saw that this is a 12-inch ruler. When I put this there, all right, my question now is this. George, you said 7, right? You willing to put your life on the line for that one? Meaning, if it ain't 7, you're dead. No? Okay. All right. Okay. Jayla, you said 5, right? You said 5 after you saw me do. Did you see me do this? Okay. You willing to put your life on the line for your 5? No? All right. Alondra, you said 6. All right. Not willing to put your life on the line. So all those numbers right there I would not consider significant because, again, they are not definitive. They are not strong numbers. Okay. When you say, mine's strong. No, it ain't. You're not willing to put your life on the line for it. Okay. So I would say this right here. Let me go ahead and go with the numbers. Okay. I'm going to go with the numbers right now. I'm going to put it right there. Everybody see that? Let me do it one more time. Go right here. Let me see that. All right. Now, Coburn. You saw that, right?
Yep.
So what do you think the distance is now?
In between 8 and 9 inches.
In between 8 and 9 inches. Okay. Give me a specific.
Like an 8.5.
8.5. All right. My question is this now. The 0.5. You willing to bet your life on it?
No.
You willing to bet your life on the 8?
It being in between the 8
And being like you know that the first number is going to be 8, but you're not sure about the 0.5.
I'm
You're
good.
not willing to bet it on the 8 either. Okay? All right? I am, but maybe it's because I was closer and I saw it. All right? Because when I take right here and I go like that, I see that your line there is between the 8 and the 9. So I know this. It ain't more than 9. And I also know it ain't less than 8. So that 8 point something, right? That 8, I'm good with. So that 8 is significant. Now, what's not significant for you is the 0.5 because I'm thinking, well, what if it's 0.4? You're like, dang, I don't want to die on a 0.4 when it's a 0.5 when I thought it was 0.5. That's what we mean by significance. Significance means how important, how strong is the number. Everybody got it? So we can't have, you ever hear the expression, you're only as strong as the weakest link? Are y'all awake? Okay, so have you heard that expression? You're only as strong as the weakest link, which means that no matter how strong your strong person is, we're going to go after the weak person. So really what determines is who's the weakest person, because that's going to determine the outcome. All right, so let's get to some of these rules. All right, when we deal with this, rule 1 is really simple. Okay, I'm going to have you kind of circle or underline whatever it is you want to do. If you got a highlighter, highlight. If you want to underline, underline. If you want to circle, you want to circle. It doesn't matter to me. But there are certain things we want to keep track of here as well. In rule 1, every non-zero, that is the key word there. Rule 1 is the easiest rule in the world. Okay, rule 1 is the easiest rule in the world because it simply says this: if the number in the number is not a 0, then it is significant. Meaning, if the number ain't 0, it counts. I'll say it again. If the number ain't 0, it counts. So when we did 1,000, correct? How many non-zero digits are there? 1. And it's the first one. So therefore, that's why this number right here has 3 significant figures. Because rule 1 says if you're not a 0, then you're significant. So let me go around the room real quick and have some people tell me some non-zero digits, just single digits. That's not a 0. Okay? Single digits that are not a 0. All right? Nigel, give me one. The question is, give me a single non-zero digit. Can't think of one? All right. You will once you hear the first one. Jayla, give me a single non-zero digit. 2. Not a 0, and it's a single digit. That's a single non-zero digit. All right. Allison. 7. Janie. 8. Nathaniel. 6. Coburn.
6.
He already said it. You don't know? All right. Sorry. Deshanti. 1. There you go. All right. India. 3. All right. Jasmine. 8. Have we said 8 already?
Yeah.
No? Yeah. Give me another one.
9.
Have we said 9 already?
No.
No? All right. 9's good. All right. Coburn. I think we only got one left. I think we got one left. We got one left or 2 left? Huh? Well, he just took his one. I think there's one more left. No, he said 1.
Oh, you did?
Or somebody said 1. Coburn. We got one digit left.
4.
All right. That was the one she just stole. Now we got 1 left. You had 2 left, then she stole that one from you. I'll give you a clue. Ready? 5 minus 2?
3.
All right, good. All right. I'm glad you didn't have to reach for the calculator. All right. Hi. Who said that one? Oh, you did? I'm sorry, India. Then I wasn't paying attention to you. I guess it's like most guys, you know what I mean? Don't listen to ladies. All right. Let's go to another one here. Let's go with that number right there. All right. According to rule 1, Zyquez, how many significant figures does that number have? Woo-hoo! Sorry. That's a mistake. All right. That should have been a 1. My apologies. However, I wish some of my people would have fixed me on that. I make mistakes. I never say I'm perfect. All right. I make mistakes. So now, Zyquez. Now that I've adjusted that and let you know now that because there's only one non-zero there, it only had one significant figure, right? Here's your new number. How many significant figures are there? 2. All right. And just to make sure you're looking at the same thing I'm looking at, who are the 2 significant figures? 1 and 2. Everybody good with that? Are we good? Let's go right here.
On the interruption, at this time, bus 404 and bus 390 are now arriving on campus. Please allow these students into your classrooms. Thank you.
Londra, how many significant figures?
In that one?
In that one? 2. Okay. There are 2 significant figures here. All right. Does the decimal mean anything? No. Not yet. All right. But right now, if it's that's what I'm saying. If it's not a 0, it counts. If you screw that one up, you ain't going to get any of them right. Okay? Like if you screw up the easiest rule of the semester, then there's a big challenge ahead of you. Okay? Any questions about rule 1? We're good? All right. Because now, here's the thing. If you look at your rules, how many rules are there? 6 rules, right? So there's 1 rule for numbers 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 1 rule for those 9 numbers. There are 5 rules for the number 0. Okay? That's why this is going to be a little frustrating, confusing. Because now it's going to be, hold on, there's 5 rules for 1 number. There was only 1 rule for 1 through 9. So that means 0 is special here. That means 0 sometimes is going to count. Sometimes 0 ain't going to count. So looking at rule 2, all right, rule 2 says this. It says zeros appearing between non-zero. Okay, so remember now, all the rules from this point on deal with zeros. So if it's a 0, you better pay attention to the scenario for the 0. If the zeros are between non-zero digits, Donovan, give me a non-zero digit.
1.
1. Michaela, give me a non-zero digit. 5. So if I've got zeros between a 1 and a 5, the rule here says they count. Okay? So zeros between. You better remember the between. Now, you know how I remember it? I call rule 2. I'll get it. I call rule 2 the sandwich rule. Okay? I call it the sandwich rule because whatever is between the pieces of bread is good. Okay? I don't care what it is. If it's in between bread, it's all good. Well, guess what? Your non-zero numbers is your slice of bread on top, your slice of bread down below. Whatever's in between is all good. All right? So what does that mean? That means if I have, I'm going to give you this one again. 1,000 had how many significant figures? 1. Okay? By the way, today is most definitely the day where if something ain't making sense, you might want to ask me then. Because again, then would be a 5-second fix. By the end of the period, it could be me having to do this for 50 minutes again to fix it. So you want to definitely get it fixed as we go. This here had 1 significant figure. But, so imagine, I go 1,000, 1 significant figure. I go 1,001. How much more is 1,001 than 1,000? 1 more, right? So just 1 more. Now suddenly, I've got 4 significant figures. All right? My number went from 1 significant figure with 1,000 to 4 significant figures for 1,001. How come? Because how many non-zeros do I have? 2. I'm going to write it right here. Those arrows, I got number 1 underneath them because I'm letting you know that's rule 1. That's why they counted. Because of rule 1. These zeros counted because of rule 2. Because those zeros now, they're sandwiched. Okay? The zeros in the number 1,000 are not sandwiched in between anything. But in 1,001, they're sandwiched. And when they're sandwiched, they count. All right? Are we good with that? So, that's rule 2. Any questions about rule 2? By the way, let me throw in here if there's a decimal in here, just so you can see the whole scenario if there's a decimal. All right? Like that number right there is 10.01. 10.01, right? Well, what's the first number? 1. What's the last number? So whatever's in between counts. I don't care what it is. Whatever's in between counts. It's called the sandwich rule. So this one here, this one has 4 significant figures also. All right? So right now, rule 1, anything that's not a 0, it counts. Rule 2, any zeros between not zeros, they count. Got it? That's the sandwich rule. Now come the rules that can be a little confusing. So let's go to rule 3. Okay? Rule 3 says this: leftmost zeros. Everybody, raise your left hand now. Okay, just had to make sure because every once in a while I'll see somebody, as I've done today. I've seen somebody today raise the wrong hand. Okay? Remember, leftmost, right? Leftmost. So you're looking for zeros on that side. Okay? Zeros on that side. Leftmost zeros appearing in front of non-zero digits. So here we go. Leftmost zeros. I'll just even underline right here. In front. Not significant. So now I got a rule here that's thrown at you what is not significant.
Art Club and Mert Club, please report to the PAC to take pictures.
All right? So now you got a rule that's telling you, like, remember, rule 1 says they are significant, right? Rule 2 says they are significant. Rule 3 is now saying they aren't. So pay attention to that part of rule 3. If you're looking at rule 3, you're now saying these things are not counting. Now let me go ahead and give you an idea of what leftmost zeros are. Okay? So I'm going to give you 2 examples of leftmost zeros. First of all, see that number right there? Right? What's the non-zero number? What's the non-zero number? 1. And what's to the left of that 1? Zeros. Those zeros you would say are in front of a number, right? They're at the front. They don't count. Okay? They don't count. All right? Now, do you remember the other day, or have we? Yeah, remember the other day when we were doing the thing where you had to move a decimal? Like remember we were doing these loops? And then you had zeros, right? So let's say, for example, I was doing loops like that, and then I had to fill in gaps in front of a 5, right there. Whether there was a decimal there or not is irrelevant. Any zeros in front of a number, okay, they don't count. If they're in front. Now, when I say in front of the number, most of the time for me, a number starts when there is a non-zero number. You see what I'm saying? Like, imagine if I did this. Like, you would look at me if I was crazy, okay? But nobody goes around saying $5 by saying 0.00005. Usually you would just say 5, right? You would ignore the zeros. But sometimes when you're moving loop-de-loops like that, you might get a bunch of zeros in front of a number. So I'm just letting you know, if the zeros are in front of a non-zero, they ain't going to count. Because if they're in front, remember, front for us means to the left of it. That's why Rule 3 says leftmost zeros don't count. Alec. Okay. Sounds like you're using your phone. All right. Any questions about Rule 3? Rule 3 is simple. Zeros in front of a number don't count. Zeros in front of a number don't count. Okay? Y'all give me that look. That look that makes me think. I'll give you let me go ahead and give you a heads up. In chemistry, which this is not chemistry, we have a section where we have to learn these rules from converting stuff. Okay? Well, we spent, and it's a difficult conversion thing. So we actually learn one rule every day. So when we do Rule 1 and spend one day on it, they're like, Mr. Science, this is easy. I got you. Then on day 2, we do Rule 2. All day, every day, Rule 2. They get the homework. Mr. Science, this is easy. I got you. Day 3, we do Rule 3. All day, every day. Mr. Science, man, this is easy. I got you. Then what happens is this. On day 4, I give them a problem. And they got to decide, do I use Rule 1, Rule 2, or Rule 3? And then they go like this. I'm confused. Okay? It's easy when you're learning one rule at a time and it makes sense. But what's going to happen here is this. I'm going to give you one number. And then you're going to have to tell me how many numbers in that number are significant. You know what that means you got to do? It means you got to use Rule 1, Rule 2, Rule 3, Rule 4, Rule 5, Rule 6, all on that one number to see which ones count. So it ain't a problem when you're doing one rule at a time. Where it's a problem is when you're having to do all the rules at the same time. Like that's why again, I would strongly suggest tonight when you're doing your homework, you have the rules right there with you. Okay? And by the time you take your test, which your test is scheduled for Tuesday next week, all right? When you take that test on Tuesday next week, those rules got to be up here. Okay? Because my tests aren't open note. Because your NC final ain't open note. You were good? So I'm just letting you kind of give you that heads up. All right? Let's go to Rule 4. Rule 4 is the most confusing rule. It's the one that everybody, including my honors chemistry kids, screw up. Okay? Now, George, in basketball, you drive to the lane. You go up for the layup. I hit your hand. That's a what? Foul. But your layup goes in. You call it a what? Who said it? And one. Right? Because that's all y'all's in PE, that's all I ever hear all day. Right? They're playing basketball. And one. That's a foul. Right? And one. What does that mean? It means you get the 2 points and you get the free throw. Right? Can you just take the 2 points and not shoot the free throw? No. Can you just shoot the free throw and say, I don't want the 2 points? No. It's you get the 2 points and you get to shoot the free throw. It's both. Not one or the other. It's both. Well, guess what? Rule 4 is what I call my and one. Okay? Which means you better remember both. Because if you don't, you're going to be in a world of hurt. Because the rule says right here, zeros at the end. Okay? When they say at the end of a number, that don't mean the front. That means the back, which means those zeros are going to be on what side? The right side. So zeros at the end of a number, but see that word right there? That's and. Means you can't choose zeros at the end and then or something else. It's got to be zeros at the end and. Okay? So zeros at the end of a number and to the right of a decimal. Okay? Zeros at the end of a number and to the right of a decimal. They count. Okay? They count. I'm going to underline it 3 times. Zeros at the end of a number and to the right of a decimal. They count. Okay? They count because they are all in the same game. All right? They are all going to be significant because those zeros, because I might need my calculator. And like I told you before, today might be a day where I have to show you how to punch in numbers in a calculator. So, not that I'm trying to treat you stupid, but I have to do it with honors chemistry too. So let me give you a number. All right. First of all, let's start with our first number. Okay. What was that number? 1,000. Right? 1,000. And then are those zeros at the end of a number? Yes. Are they to the right of a decimal? They are to the right of a decimal? Okay. Here's my question. Where is the decimal right now? Behind the zero. In other words, it's right here, correct? Are they behind the decimal? No. So, do those zeros count? No. That's why this still will always be one significant figure. All right? Now, see that number I just drew on the board? 1.000. Okay? Those zeros, are they at the end of a number?
Yes.
Yeah.
Yes, they are. Are those zeros to the right of a decimal? Yes, they are. So do they count?
Yes.
Yes, they do. That's why this one here has 4 significant figures. Here's the one that most of you are going to get wrong because you're going to be saying, you're going to get them confused now. So here's what's going to happen, all right? Let me give you this number that I gave you before. Okay? 0.0001. Okay? See those numbers? See those zeros? Are they to the right of a decimal? Yes. Do they count? No.
Please excuse the interruption. Teachers, please do not release any students for pictures until that club has been called. Thank you.
All right. Those zeros are to the right of a decimal, but they don't count. India, why don't they count? They're to the left. They're not at the end of the number. They're at the front of the number. You follow that? You have to satisfy both things up here. It's got to be at the end and to the right. If it's just to the right, it doesn't count. If it's just at the end, it doesn't count. It's got to be at the end and to the right. So this number right here has one significant figure. Okay, that number there has only one significant
At this
figure.
time, Battle of the Books and National Art Honor Society, please report to the gym to take your pictures. Thank you.
Now here's one that's going to confuse you even more. Before I get to that one though, let me get to Janie's question.
I'm in Battle of the Books.
All right. All right. I mean, like I said, they called you. You're good. So here we got a number. Okay. Just for giggles, Coburn, tell me what's that number on the board. 100. All right. And so now, here's the thing. Take 5 seconds and think, how many significant digits do you think are in that number? I'm pretty confident you're going to be wrong, because I would be wrong too, based on what you know so far. So right now, if you're going to guess, how many numbers do you think are significant? All right, I heard a 1. I saw a 2. Anybody else got a 1, a number besides 1 and 2? Victor says 4. Okay. All right. So here we go. Who said 1 over here? You did. All right. Which is the 1 significant for you? The 1. Okay. He's going that one's significant, right? Now here's my thing. You should be able to defend any number that you count as significant, you should be able to defend by giving me a rule. If you can't give me a rule, you're talking out of your butt. And I don't believe you. That means you guessed. Okay? What rule backs up your claim? Rule 1. Anything not a zero counts. Got it? Donovan, you said there were 2. I assume that's 1.
Yep.
Who was the other one?
The 2 at the front of the decimal.
The 2?
I mean, the 0 at the right of the decimal.
The 0 at the right of the decimal. Okay? All right. Hold on. Let me go ahead right here. I'm going to write number 1 right down there. Why is that 0 counting?
Because it's at the end of the number and it's at the right of the decimal.
Okay, so you're going with rule 4. All right? And that's where most of you, I guess, were saying, I'm good with those 2, right? Victor, you said there were 4. Okay, I'm assuming the other 2 count for you. Why do they count for you? Huh? Because of rule 2? All right. He says these count because of rule 2. And he's right. Okay? And I now understand. This is why I said some of you might get confused, right? Some of you are going to say, hold on, but rule 2 said like between non-zeros, right? And I agree. That's what the rule says. But once that number is significant, basically rule 2 should say this. Zeros between significant numbers count. Do you follow that? Like I know the rule says zeros between non-zeros because that's what the rule says. But I'm letting you know the rule should say zeros between significance count. And so because that 0 is significant, then the sandwich rule does apply here. And therefore this does have 4 significant figures. Okay? Now, I understand that may not make sense right now based on what I taught you, which is the reason why I said I would expect most of you to get that one wrong. But now that I've thrown it at you, you remember this. Once you got a significant and once you got a significant, anything in between is good. Okay? Once you got a significant and once you got a significant, anything in between is good. All right? Are we good with rule 4?
At this time, CTE Honor Society can go to the gym to take pictures.
All right, let's go to rule 5. Rule 5 is just a weirdo. Not weird, but just... All right. Zeros. Here's the thing you got to remember about rule 5. That's the word you want to circle, highlight, or whatever you want to do. Okay? I forgot your name. No, that was my computer. Okay. I was going to say, I thought you sent me an email, but it was a computer. That's why you did email. All right. There you go. Also, if you got your homework for Friday, then go ahead and have that out and just calmly come pick it up from me because I already collected it. All right. Understood. Who remembers what we said about that on Friday? That will let me know that you actually paid attention. I'm not talking about rule 5, about those 2 words that I just circled. We talked about it on Friday. Who remembers? Nobody remembers? We did it at the beginning of class too. Okay?
The decimal bar on the first zero at the end.
Okay. Hey, hold on. For our class, all right, in this room, right? We read numbers like we read words, right? Like, I start from my left and go to my right. Okay? So if you say first, I mean that one. Okay? Just the way we talk. I'm fully aware in mathematics, that's a single, that's a 10 place, that's a hundreds place, right? And usually when you're dissecting a number, you go from there to there, right? But when we're reading a number, we're reading it from left to right. So when you say first 0, I'm looking at that one. If you say second 0, I'm looking at that one. You get what I'm saying? So just in this room. All right? So, we said on Friday. Who haven't I called on today yet? Kevin. Kevin, do you see a decimal? That's a yes/no question.
No.
No, you do not see a decimal. Michaela, is there one?
Yeah,
Where is it?
behind the second zero.
Behind the second zero, right? Don't see it, know it's there, that's understood. Everybody understand what I mean by understood? Because that's what Rule 5 is all focusing about. Rule 5 is focusing on what about zeros when there's a decimal, what about zeros when there's not a decimal. All right, so Rule 5 says this. This right here, the number 500, you do want to include in your notes. Okay, the number 500 here has one significant figure. Why? Because those zeros are at the front of an understood decimal. And because they are at the front of an understood decimal, they are not significant. All right. By the way, Coburn, what's the number again? 500. All right. It's as simple as that. That's the number 500. Does it have a decimal? No. Okay. Is it an understood decimal? Yes. That's why 500 has one significant figure. But guess what? If I do this, do you see a decimal? Yes. So is it understood now? No. It's not understood. It's there. And because it's there, these zeros, now they do count. Okay? When there's a decimal there, the zeros count. It hasn't even changed the value. It's 500 up here, it's 500 there. So what's the difference? The difference is that one don't got a decimal and that one does. The decimal being there matters. The decimal not being there matters. Even though it's the same number, the decimal being there matters. Let me tell you why. Okay? Because in math, when you don't put a decimal there, that number is not as strong. Because you know what 500 means? 500 means could be 501, could be 506, could be 497. Because all those numbers, when you round them, we're going to round to what? 500. Right? So 510 rounds to 500. 490 rounds to 500. Okay? But when I say 500 point, you know what that means? That means I mean 500. I don't mean 501. I don't mean 499. I mean 500. That's what the decimal means. It means there ain't no range. It's that and only that. This means there's a range. Okay? That's why those zeros don't count, but in here they do count. Because that one's saying, there's no mistake. That's 500, not 499, not 501. Here, it could be 526. Because 526 is still going to round to 500. It could be 476. 476 is still going to round to 500.
At this time,
Are we good?
National Honor Society
That's what Rule 5
is
says.
common ground.
Okay.
Please report to the gym and take your pictures.
Rule 5. Are we good with Rule 5? All right. Now, what's number 2? Or wait, what's number 3 on our goal for today? Number 3 on our goals. Not Rule 3. What is goal 3 today? It's on the handout.
Know how to round.
Sorry, Coburn, you said something, but then I didn't hear a word you said.
Know how to round to significant figures.
Know how to round. Circle that word round. Okay? Because this is the part. Rounding is important because after Rule 6, by the way, Rule 6 is simple. Okay? Because Rule 6 rarely applies in what we're doing. Because we're always having to do calculations. Okay? So, Rule 6 says this. Unlimited, right? Unlimited. You know what that means? Could be 1, could be 1 million. Okay? Because, and this is an example of it. If I go around and count the room, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, right? How many people in the room?
17.
Slow child. Don't count me. I count as 2. Okay, count me and I count as 2, right? So how many would that be? 18. Okay? 18. How many significant digits in that? 2. However, could be 18.0, right? Because can we have half a person in the room? Can we have a quarter person in the room? No. How many did we count? 18. Right? So 18.0. How many significance? Uh-oh. How many? 3, because the 0 is at the end and to the right of a decimal, right? So it counts. If I add a 0, how many significance? 4, right? I can keep adding zeros, couldn't I? And I would still be right. Because how many people were in the room? 18. Not 18.1, not 17.9. There were 18 because I physically counted 18 people and I can't have a percentage of a person in the room. So that's why this would be unlimited. I can add as many zeros as I want to. Because when you physically count something, that is as exact as you can be. And it'll be 18, 18.0, 18.00, 18.0000000000, right? I mean, that's how it is. Okay? Now, let me throw one other thing before I get to rounding. Okay, let me get to one other thing before I get to rounding. So I'm putting this to the side. Actually, you know what? I need to do this. I'm going to cover up my video right now. Not my video, but my screen. All right. So let's look at a scientific notation number. All right. See that number right there? That's what we learned on Friday, correct? Okay. Right now, take 10 seconds and think. It's a guess. Okay, it's a guess. Take 10 seconds and think. How many significant digits are in that number? Don't say it out loud. Think to yourself. Got a number? All right, here you go. You ready? You're gonna. I don't want that way. Nobody admits whether they were wrong or right or whatever. There are 3 significant digits in that number. Okay? Because in a scientific notation number, the only numbers that I care about are the integer. Okay? When I'm trying to determine significance for a scientific notation number, the only number I'm going to look at is the integer. I don't care about them right there. I will never look at the power of 10 and the exponent. Never. It's always just the integer. That counts, rule 1. That counts, rule 1. That counts, rule 4. It's at the end and to the right of a decimal. Are we good? So, questions about that? Just want to make sure we throw that out there. Do me a favor. It's not in your handout. Make a note. Scientific notation, only look at integer. Okay? Scientific notation.
At this time, Drama Club and
Only look
Recording
at
Studio,
integer.
please report to the gym to take your pictures.
Okay. All right, here we go. You ready? We have a significant digit number. We have a number up there, right? So write that on your paper because I'm going to teach you how to round now because rounding can be frustrating. There are a lot of things in this thing can be frustrating. Rule 4 can be frustrating. Rule 5 can be frustrating. Okay? Having to deal with scientific notation can be frustrating. That's why I'm saying today, if you ain't frustrated doing your homework, I'm going to say this. I'm going to bet money is because you're doing it wrong. All right? Rather than you're doing it right. Because if you're doing it right, you should be really overthinking things. Okay? Donovan, your hand up?
Yeah, is that 6 number 6?
Yeah, that's a 6. I'll rewrite it. I accidentally put a 0 and I tried to make it a 6, so, I was lazy. All right, we good? Everybody got the number written down? Okay. So, I'm going to somebody in the front row because that way I don't have to have issues with sight going on here. So let me go to Nathaniel today, or this moment right now. I've gone to Cobra about like 6 or 7 times already. Nathaniel, how many digits are in that number? And somebody else count to verify that because I haven't counted.
12? No, 8.
Okay, that ain't it. I know that part. Okay? Like, that's all one number. Okay?
12 digits.
Nah, there's more than that.
Hold on. 8. 15 actually.
Okay, there you go. All right, I know what you were doing. You were counting the numbers, right? But again, so in case you are doing the same thing, there was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay? There are 15 digits in that number. We're good? How many of those numbers are significant? Say it to yourself, not out loud. Say it to yourself, not out loud. How many of those numbers are significant? Alondra. 8. She's going 8. All right. Zyquez. What's the first number? 1. Okay. That's not a 0, right? Okay. Zyquez. What's the last number? 2. Last digit. 2. That's not a 0, right? So anything in between counts. So what does that mean? It means they're all significant. Okay? That's the first. That's not a 0. So the sandwich rule says that everything in between counts. Okay? So there are 15 significant digits in that number. Okay? Are we good right there so far? So here's my point. Remember we said that you're only strong as your weakest link? So here's my issue. What if I can only have 9 significant digits? I've got 15. I can only have 9. So my number's too big. All right? So here's how we round. Round to 9, okay? So I'm going to show you how we round to 9. Remember I said when we read numbers, we start from what side? The left, right? So here's my first, second, third, fourth, fifth, sixth, seventh, eighth, 9 significant. Okay? Those are my 9 significant numbers. God bless you. Are we good with that right there so far? Once I see my 9th one, you know what I do next? Is I look to the neighbor. What is the number next to the 9? A 1. Because that 1, that number, is going to tell me whether that 9 needs to round up or whether it needs to stay the same. You see what I'm saying? So right now, I've got 1, 2, 3, 4, 5, 6, 7, 8 point, and now I got to determine, is it going to say 0.9 or is it going to round up? It's going to stay 0.9. Okay? It's going to stay at 0.9. What number would that have to be to cause that 9 to round up? 5 or greater. Okay? 5 or greater. Just want to make sure. And the other thing here, and because it happens every semester, so I'm just trying to say, because that number is a 1, that don't mean the 9 rounds down to an 8. It just stays the same. But it happens. India, what up? What if it was a 5? Then I'm going to show you what to do. Okay? I would show you what to do. Okay? I'll say it, but I ain't going to write it because I don't want to be committed to it in front of the class right yet because that's going to confuse them. Right now, what you would do is you would say that 9 is going to round up to a 10, right? But I can't write a 10, so I'd have to change that 8 to a 9. And then I would make that 9 a 0. And then that 0, because it's to the right of a decimal, would still count. Okay? But you're going to get a weirder today, so don't worry. All right, so here we go. Let's say this, though. Let's say we had to round to 6. All right, so let's just say in another problem we're doing, we got a long tail number. But I can't have a long tail number. I can only have 6 significant digits in my answer. Okay? So, for me to round, right, who are my first 6 significant digits? They're going to be right over here, right? 1, 2, 3, 4, 5, 6. Then I got to look at the neighbor. Who's the neighbor? 7. What happens to my 6? It's going to round up to a 7. So here's what my answer would be. But if you stop there, you're going to be wrong. Okay? Because now, am I using the 7 and the 8 in my answer? No, because remember, that was the last number I looked at, right? That number and that number I'm not using. But because those numbers are in front of a decimal, I can't just erase them. I still have to hold their spot. What should I hold their spot with? A 0. So therefore, that would be that answer, rounded to 6 significant digits. All right? So you got to realize this. If you're taking away numbers in front of a decimal, you got to hold them spots with zeros. Because if you don't, well, think about it like this. George, if that were your salary, I'd owe you $12,345,700. Okay? But if I don't put them zeros down, I just owe you $123,000. Is that a difference? That ain't a difference to you? It is a difference. I was going to say, like, if I owed you $12 million, I only give you $100,000, you're going to be looking at me going, where my other $11 million at? Right? So that's what I'm saying too. When you give me this as your answer, I'm saying, hold on, where my other $11 million at? You got to give me them zeros there. That's the right answer. If you forget to put the zeros, which many of you will, that makes your answer wrong. Why this is frustrating is this. Either you're right or you're wrong. There ain't no close. Okay? There ain't no close. Okay? Like to be mean, I would say it's like this.
Could you please release FCA and SAD students to the PAC for pictures?
I'm not trying to be mean, just trying to be real. Either you're pregnant or you're not. You can't be kind of pregnant. Right? So again, your answer is either right or it's wrong. You can't be kind of right. Either right or you're wrong. Are we good? That's what I'm saying. This is where it's going to be kind of frustrating for you. All right? Let's go right here. Here's what I want you to do. I want you to round to 4, and then I want you to round to 2. All right? I'm going to have you do that one on your own. Just kind of go and see what you get, and then we'll see if you're right. And if you're wrong, then you might want to ask a question. Because if you don't ask a question, then you ain't going to get fixed. So again, you're just rounding to 4 and rounding to 2. And if when I walk by, if you want to stop me and say, hey, is this right? I'll even tell you. Remember, you gotta add some zeros on there. And the second one, you shouldn't have rounded that second number because what's the number after the number? You know what I'm saying? All right. Here's how it rolls over here. I need to round to 4, right? First, second, third, fourth. There's my number, my neighbor, right? 1, 2, 3, 5. 0, 0, 0, 0, because I got to hold them spots. Because again, George wants his 12 million, not his 100,000. Okay? Rounding to 4, that's your answer. If you got it wrong, might want to ask now to see what you did wrong. Because remember, tomorrow, like I said, you got homework. I'm going to say it more like this. You got practice. You ain't got to practice. But tomorrow when you get the 5-question game, you ain't going to be ready. Okay? Any questions on that one? So you might want to get it fixed if it is broke. So we're straight. Round to 2. If I want to round to 2, 1, 2. There's my neighbor. My neighbor's a 3. Does my 2 got to change? No. 1, 2. But if I leave it there, George, if I paid you that much money, would you be angry? If I paid you that, $12, would you be angry? Yeah, because what do I owe you? I owe you 12 plus, 6 zeros behind it. Okay? Like, there's a big difference. All right, I mean, some of you would be angry if I gave you $12, but I owed you 120. Imagine if I gave you $12, but I owed you 12 million. Okay, that's a big deal. Questions on how to round? All right, let's take a look at your adding and subtracting, because it really just involves rounding. And you're multiplying and dividing. God bless you. So in these rules, it literally means find your weakest link. So, matter of fact, you know what? You got the notes. I ain't even put this up there. Don't know if I have practice problems or not. So look at, is it first adding and subtracting? Okay. All right, so here we go. I'm going to throw 4 numbers up on the board. I'm going to go 15.1, 2.77, 0.666. Ooh, that's Allie's number. And 129.3. All right? We're going to add up all them numbers. Do me a favor. Please use your calculator and add up the numbers and then be ready for me to ask you, what did you get? By the way, if I don't ask you, you still better verify if the person giving me the answer is right. If you don't got it, say I don't got it. So I can ask anybody in this room and you ain't going to say I ain't got it. Great. Victor, what you got? Okay, go ahead. Got it? It didn't work. All right. George, you got it? Go ahead. Tell me what you got.
47.8.
That's what you got? Everybody good with that? Okay. You ready? The whole point of today's lesson is significant figures, correct? So if you gave me that answer, you're wrong. Okay? You'd be wrong. You said, but I added up all the numbers, man. You even use the calculator. I know. You're wrong. Because you have too many significant digits in there. So the question is this. Well, how many significant digits am I supposed to have? Well, let's take a look at the rule. It's on your paper. Okay? The rule on your paper says the answer when adding or subtracting should be rounded to the same number of decimal places as the measurement with the least number. Least number. Got it? How many decimal places does that number got? 1. How about that one? How about that one? How about that one? So what was the least number of places that a number had? 1. So that means my answer can only have one number behind the decimal. What number is that first number behind the decimal? 8. Ready? 8. But who's the neighbor? So does my 8 change? So therefore, my answer then would be 147.8. That would be the answer. And it's the same thing if you're subtracting. Okay, if you're subtracting, basically all you got to do when you're adding and subtracting is just say, how many numbers behind the decimal do my numbers have? And whichever one is the least, then that would be the one that I have to round my answer to. Okay? Now, I'm going to adjust my number up here just for the sake of you seeing something. All right, even Victor. Hopefully he'll see it. All right? Let's say my number was this. Let's say that was the number. Not 15.1, just 15. How many numbers behind the decimal? 0. So how many numbers can I have behind the decimal? 0. So that means I would have 147. That's my last number I can keep, right? Who's the neighbor? So what would my answer be? 148. Because I would have to round that up. Okay? So I'm just letting you know. That's kind of how the rounding of adding and subtracting works. You're going to get some practice. That's why you get a sheet today. Okay? Let's do multiplying, though, because multiplying is a little bit more dicey. Okay? So let's go with this. Let's go with 138 times 100. Okay? 138 times 100. When you get that answer, raise your hand so I can write it down. George, go ahead. Okay. So 13,800. That what you got? Great. If that's what you write, you're about to be wrong. Okay? The rule is different for adding and subtracting compared to multiplying and dividing. When we multiply and divide, we got to do this. See this number right here, 138? How many significant figures are in that number? 3, because they're all not zeros, correct? So this has got 3 significant figures. How many significant figures are in the number 100? 1, because the zeros don't count. So I used 2 numbers to get 13,800, right? One of those numbers had 3 significance. One of those numbers had 1. So which one do you think determines my final answer? The one with the 1. So what does that mean? This answer right here has how many significant digits in it? 3. But it can only have 1. So I need you right now to go ahead and round that number to 1 significant digit. Do that now, because I want to see if you're getting the hang of it. Because some of you, I'm pretty sure, aren't. Because nobody ever usually does. It's okay to be wrong. It's okay to be wrong. Alondra, I got an answer. You don't? Uh-oh. She had confidence at the beginning of class. It's gone. Wait. Juanwood. I'm just joking. I don't care. All right. Got an answer? You ain't got it? Who's got an answer? Who's got some confidence? Coburn. 10,000. We're going to take that out and put 10,000. That would be correct. Let me review again for you the rounding procedures again, right? How many significance are we rounding to? 1. Who's the first significant digit? The 1. Who's the neighbor? So what happens to my 1? It stays the same. So I drop the 1, right? But I got to hold them spots, because remember, all them zeros right there would be in front of a decimal. I got to drop them zeros and hold that spot. So that's why my answer would be 10,000.
Interruption at this time. FCCLA and Salt Club, please report to the gym and get your pictures taken. FCCLA and Salt Club.
Give me what? I'm sorry, I didn't hear you. You thought the 1 had to round it to a 2? Yep. No. Remember, if the neighbor is 5 or higher, then the number's gonna have to round up. Okay? Yeah, because it's a 3, it doesn't have to change. Now, if it would have been 15800, then the 1 would change to a 2. Okay? So yeah, so it's kind of that same rounding thing we did in grade school, where it's like 5 or higher. I forgot how y'all said it. I didn't go to school in North Carolina, so that's why I don't have issues with math. But nonetheless, are we good? Yes? Okay. I'm going to do one more. Okay? One more. Because I want you to see now how Friday and today connect together. Shoot. Yeah, I can do that. All right. Go ahead and calculate an answer for that. Don't worry about the rounding thing. Just calculate an answer like you would have done on Friday. Ms. Holmes, what's the first thing we do? I mean, just tell me. You don't got to tell me like exactly. Just what's the first thing we're supposed to do? Divide what? Divide the integers. Okay? When you do that, tell me what you get in your calculator now. 2. Okay. And then, Jayla, what's the next thing we do? Subtract the exponents. When you did that, what did you get? -2. Okay? That's what I meant to do, dang it. All right, no. So, how many, my answer, good as it is, or do I got to change it? What do you think? Some of you don't know now. Some of you, I don't know, man. Hence the reason I'm telling you. You can have a right answer, and some of you won't even know it. Some of you will have a right answer, and then you'll change it. Did somebody just not? Okay. Some of you will have the right answer, and then you'll change it. Because this stuff screws with your minds. Okay? It screws with your minds. So my question, Allie, my number good or do I got to change it? That's a either or. Good or change. Those are your two answers.
I think good.
Good? She says good. Donovan, good or change?
Say good.
You say good. All right? How many significance does that number have right there? How many? 3. Because they had the end into the right of a decimal. 3. How many significance that one got? 1. So how many can my answer have?
1.
How many does that one got?
2.
1. So I'm good. Okay? I'm good. Ready? Let me light your world up. What number is that? 1,000. Do me a favor. Round that to 2 significant digits. Even if you're not sure, just put what you think you know would be your answer. Everybody good? Some of you might be still thinking. That's okay. Alondra's got an answer. Alondra, give me your answer. 1.0. All right. I'm going to go to somebody else. Daniel, you look like you got an answer. What's your answer?
I ain't get one yet.
You didn't get one yet. All right, Kevin? Come on now. You got to get something. Donovan, you got 1,000. Like 1000. Okay. Nigel, you got 1.0? Okay. India, nothing. Jayla, 1.0. Okay. George? 1.0? Okay, so here's my question. How much money is that? $1. So we're good? If I owe you that, if I give you that, we're good? Got to add some zeros? Okay. Guess what? How much is that? Still $1. You see the issue? The issue here is this. Guess what that is? That's still only got one significant. Because them zeros don't count. Right? So that's one significant. That's 4 significants. So in the original answer was 2 significants, but it ain't 1,000. Okay? I'll say this. There is no place you can put a decimal and get this to round it to 2 significant digits. When you can't do it at all, then the one thing you got to remember is Friday's lesson. Okay? Because you know what? That is 1,000. And that is 2 significant digits. And that is the only way you could round 1,000 to 2 significant digits, is you'd have to put it in scientific notation. You will, every once in a while, get one of those pain in the butts. So I'm throwing it out there so that way you're aware of it. When you go, man, that's impossible, man, I don't know how to do that, then you better remember that thing called scientific notation that we learned on Friday, because that's probably what you're supposed to be doing anyway.
Okay. Interruption at this time. FFA and SGA, please report to the gym to get your pictures taken. FFA and SGA club.
All right, guys. Give me your sheets. What time is it? Look on your phone, because my clock doesn't always work right.
9:44.
9:44. So you got 11 minutes to be working on this to see can you get the hang of it before it hangs you. Oh crap! I'm still recording. That's what we're up to. All right. So I would strongly suggest, like right now, just use your time now, because again, if you know I'm planning on giving out a key, if you got a question, this ends the recording of this video.